your query goes from 200 milliseconds to 30 seconds overnight, forcing CPU consumption to spike and your API to start timing out. Inside the execution plan, you see the operator everybody blames, hash match. So you remove it. And somehow the query gets even slower. Because sometimes hash match is not the problem. Sometimes it's the only thing keeping your query alive. Not understanding why SQL Server chooses hash match can make you miss the bad assumptions that caused it. Most developers look at execution plans completely backwards. They open the plan, find the biggest operator, and assume this must be the bottleneck. But execution plans don't work like that. SQL Server is constantly making cost-based decisions. Every join, every scan, every seek. It's basically SQL Server saying, here's the path I thought was cheapest. And that word matters. Thought. Because SQL Server makes decisions using estimates, not reality. And when those estimates are accurate, hash match can be incredibly efficient. But when those estimates drift away from reality, hash match can suddenly become catastrophic. And understanding why the optimizer picked it is where real performance tuning begins. Eventually, every growing system hits the same wall. Queries that used to feel instant suddenly become expensive. Nested loops start falling apart. Merge join may not even be an option. So, SQL Server needs another strategy. Something built for huge joins, unsorted data, messy workloads, and millions of rows. That strategy is hash match. And this is where most developers misunderstand what SQL Server is actually trying to do. The optimizer is not choosing bad operators. It's trying to survive with the information and access paths available. Hash match is how SQL Server can join millions of rows without searching millions of rows. It transforms massive joins into insanely fast lookups. And once you see the two phases behind it, you'll understand why hash match scales to handle billions of rows. The hash match strategy is simple. First, it builds an in-memory structure optimized for speed. Then it probes that structure to find matches almost instantly. Two phases, build, probe, and together, they're the reason SQL Server can scale joins across millions of rows without collapsing under the workload. It starts off with the build phase. SQL Server takes rows from one side of the join, usually the smaller side, hashes the join key, and drops each row into a bucket. Rows with similar hash values land in the same bucket. By the end of this phase, SQL Server has built an in-memory hash table optimized for speed. Now comes the probe phase. The second table starts flowing in. For every incoming row, SQL Server calculates the same hash value, jumps directly to the matching bucket, and checks for matches. That's the core mechanics. Build, probe, match. And this is why hash match scales so well. Instead of repeatedly searching millions of rows one by one, SQL Server turns the problem into fast bucket lookups. And that scalability is exactly what makes HashMatch so misunderstood. Because the moment developers see it handling huge amounts of data, they assume the operator itself is the problem. Not true. Sometimes it's the best possible operator SQL Server could choose. Nested loops can collapse under huge repeated lookups. Merge join depends on sorted inputs, but hash match is flexible. And that's exactly why SQL Server uses it so often in analytical workloads and large joins. If you see hash match in a plan, don't panic. Not yet. Because the real question is, why did SQL Server think this was the cheapest strategy? And that's the question advanced performance tuners ask. SQL Server doesn't know actual row counts ahead of time. It guesses. And if the math is wrong, the optimizer can start making terrible decisions. Imagine the SQL Server optimizer looks at your query and predicts, easy, this will touch about 5,000 rows. But reality hits, and it's actually 50 million rows. Now, the execution plan is struggling. And that's why hash match can become catastrophic. Not because hash match is inherently bad, but because the optimizer built the plan using completely wrong assumptions. All three join operators solve the same problem differently, but SQL Server picks whichever one it thinks is cheapest. And again, that word matters. Thinks. Nested loops are blazing fast for small result sets and can be incredibly efficient with the right indexes, but they start struggling when large scans enter the picture. Merge joins are often the fastest join strategy SQL Server can choose. They're efficient because it does very little extra work, but it depends on both inputs already being sorted. And hash match is built to handle massive data sets efficiently. It performs well even when the data isn't sorted, but it can become expensive on memory and CPU under heavy workloads. And this is why no join operator is universally good or bad. They're strategies. The optimizer is constantly choosing trade-offs. Here's where real tuning starts. Don't immediately force another join operator. Instead, dig into why the optimizer chose the strategy in the first place. Because the real problem usually isn't the operator, it's the assumptions that led SQL Server there. This is one of the most powerful things you can learn in SQL Server tuning. Look at estimate rows versus actual rows. If they're wildly different, you've probably found the real issue. And once estimates drift far enough from reality, everything downstream starts breaking. This is where hash match becomes dangerous. Hash match needs memory, potentially a lot of memory. And when SQL Server underestimates row counts, the hash table no longer fits in RAM. That's when spills begin. Look for these execution plan warnings. Those warnings mean SQL Server started writing hash data to disk, and disk is dramatically slower than memory. A query that normally finishes in milliseconds can suddenly take minutes once spills begin. Hash spills don't happen quietly. They light up tempdb. So keep an eye on it, because one bad query can suddenly impact the entire server. Spills create contention everywhere. Sometimes SQL Server overcorrects. Instead of granting too little memory, it grants way too much. Now one query reserves massive amounts of RAM, while other queries wait for resources. If the query barely used the memory it requested, that's another sign the optimizer's assumptions were inaccurate. And once again, bad estimates create bad plans. SQL Server might choose hash match simply because it has no better access path. Then hash match becomes the least expensive strategy remaining. And this is why one good index can completely reshape an execution plan. Hash match won't magically go away. You'll just change the conditions enough for SQL Server to choose a different strategy. Statistics are how SQL Server estimates reality. So when statistics become outdated, the optimizer starts making decisions using bad math. And once estimates are wrong, the entire plan can unravel. This is why advanced tuners obsess over cardinality estimates, because execution plans are only as smart as the information SQL Server has available. Most developers stare at execution plans looking for bad operators. Advanced developers look for bad assumptions. That's the difference, because operators are outputs, not root causes. So stop asking, how do I remove hash match? And start asking, why did SQL Server think this was the cheapest plan? That question changes everything. And once you understand how the optimizer thinks, execution plans start making a whole lot more sense. And you begin thinking the same way SQL Server does. If this video changed the way you think about execution plans, hit like, subscribe, and turn on notifications, because next we're breaking down the operator that quietly destroys OLTP systems at scale: nested loops. Thanks for watching and taking another step in transforming your curiosity into expertise.